Hey everyone, and welcome to Organic Chemistry on YouTube. Today we're going to talk about SN1 reactions, the stereochemistry that's associated with them, and their substrates, alkyl halides. First of all, SN1 reactions are a type of substitution reactions. Typically will replace a halide, which is an example of a leaving group, with a nucleophile. In general, these produce a trigonal planar carbocation intermediate, and this carbocation reactive intermediate will then serve as the basis by which racemic mixtures are produced because the carbocation itself can be achiral. In general, this type of reaction prefers weak nucleophiles and polar protic solvents. Examples of weak nucleophiles are ethanol and polar protic solvents. An example could also be ethanol. So a pretty typical example. So the first thing we should cover is the order of reactivity. In general, if all things are equal, tertiary alkyl halides will react faster than secondary alkyl halides and much faster than primary alkyl halides. In fact, primary alkyl halides will never undergo SN1 reactions unless the resulting carbocation can be stabilized through resonance. So this red X refers to primary alkyl halides that are not allylic. So let's go through the typical example. We could have a tert-butyl bromide, which reacts with methanol at elevated temperatures to afford this methyl ether. So how does this reaction work? The tertiary alkyl bromide, the first step in SN1 reactions is the leaving group has to leave. When this bromine leaves, you're left with a tertiary carbocation. This has a positive charge. In the next step, methanol, which is floating around in the solution, can attack from the top face, or it can attack from the bottom face of this p orbital. And this gives two different products. Okay, and in the last step for both of these reactions, the bromine anion will come in and deprotonate this acidic protonated alcohol. And because the carbocation is achiral, this methyl approaches from either side, leading to a one-to-one mixture of these two products, which I've put in this blue box. So in general, SN1 reactions are going to give racemic mixtures, again, assuming an achiral carbocation. And that's because the activation free energies are identical for whether you're attacking from the top or the bottom face. I have just a few questions that you might want to ask in office hour. One, how does the stereochemical outcome differ for SN2 reactions compared to SN1 reactions? How can I tell if I have a strong nucleophile? Are there any general rules for understanding this? 3, how is a nucleophile different from a base? This will be particularly important as we get to elimination reactions. And 4, what if the substrate has another chiral center? How does this impact the stereochemical outcome? With that, that's been Organic Chemistry in 5 minutes or less. Thanks for tuning in.